All right, we are back. I'm going to teach you lesson 12-3. I hope you guys are doing okay. I hope you've been able to get the lessons done so far that we've done up to this point. Like I said, if you ever have any questions, you're welcome to email me or give me a call, and we can do that. Okay, first part, before we start lesson 12-3, we need to make sure that you understand a few ideas about diagonals and about some angles. So the next problem will deal with some angles. We're going to talk about these diagonals. It says, name the diagonal segment for each figure. Well, the diagonal segment, diagonals skip a vertice. So you start at any vertice and you have to skip a vertice to go to another vertice. So if I go from A to D, that's not a diagonal because I'm not skipping a vertice. But if I go A to C, that's a diagonal. So A, C would be the diagonal for that problem. Or you could say CA. Either way can be said. Another diagonal that could be drawn in, would be D to B. Anyway, on this figure, the diagonal right now that's shown is HF, or could be FH. And there's lots of diagonals on this problem. Like a diagonal could be drawn in from H to E, H to K, H to J. But a diagonal could not be drawn in from H to I because you're not skipping a vertice. Anyway, to get a diagonal, you have to skip a vertice. Connect two vertices by skipping one vertice. That's probably the best way to say it. All right, in this diagram, give another name for DE, and then I do want to talk about the angles, even though it's not asking about the angles. So another name for D to E. D to E is this segment right here. We could say E to D. And that's probably the main way you could say it if we're just talking about D to E, that segment only. Does that make sense? What's another way to name C to E? C to E could be E to C. You can name it either way. It doesn't matter which way you name it. I do want to talk about the angles. If you remember back when we learned about two lines that cross each other, anytime two lines cross, vertical angles are created. So this angle right here, AEC, so the measure of, and I really don't know the measure yet, so I'm not going to give a number. So angle AED is congruent to angle, and I'm going to say BEC. Those two angles are congruent. Those aren't the only two, because also this angle right here, and I'm going to put 2 marks on it, is congruent to this angle up here. And I mean, I could say the letters too, but that's how you name an angle that has multiple angles at angle E. When you have multiple angles at one spot, which we have multiple angles at point E, then what you have to use is 3 letters, and the middle letter has to be the vertex. So every angle up here would have to have a middle letter with a letter of E to describe it, okay? So don't forget about vertical angles. Vertical angles are ones that are across from each other. And then also don't forget that angle DEA would be 180 degrees with, or supplementary with, angle AEB. So we've got lots of things that you could discuss about that one picture, okay? All right, those 2 things are very important to be going on to the lesson. The lesson today is called Proving Triangles Congruent by, and this is really important, side, angle, side. And notice the angle is in the middle, and we call that included. Included meaning it has to be between the 2 sides that make it. And so down here's an illustration of that, and you can see that right here. So we're going to talk about that. For these 2 triangles to be congruent, the first way we learned about triangles being congruent, the first way we learned was all the sides had to be the exact same markings, and all the angles had to be the exact same markings as far as they had to match up with one another. So if there was one angle mark here, there had to be one angle mark on the other one. If there was one side mark on one, there had to be one side mark on another one. But all 6 parts had to show up. Well, now there's some shortcuts. This is one of the shortcuts to teaching us how to tell if 2 triangles are congruent. Well, the first shortcut is side, angle, side, and the angle has to be between the two sides. So if you'll notice, there's one side mark, two side marks on this side, and then the angle that is created by those two sides is one mark. Over on this picture, we have the exact same thing. So we have one side mark, two side marks, which match up over there, and then the side that is, the angle that is created, the angle that's created by the two sides is one mark, which matches that one exactly. This would be a great illustration of side, angle, side, because the angle is included between the two sides. That's the main thing that you have to get from this lesson in this diagram. Okay? So we would say that these two triangles are congruent, and they're saying that right here. Based on these markings up here above, so a side AB is congruent to side DE, angle A is congruent to angle D, and then side AC is congruent to side DF. Therefore, triangle ABC will be congruent to triangle DEF. Now, it never matters how the first letters are given. It will only matter how the next three letters are given. So always keep that in mind. And then you can tell what matches up right here. Angle A goes with angle D. Angle B goes with angle E. Angle C goes with angle F. As well as sides AB goes with sides DE. You can see that right there. Side CB goes with side EF. Side AC, you can see that has the two marks, goes with side DF, has the two marks. It's pretty unique that you can see that right from the statement. We call that the statement, okay? All right, we're gonna move on to this. All right, we're gonna decide if we can tell if these two triangles are going to be congruent. Notice that the diagonal makes them. And what I want to point out about a couple of things on this is the diagonal is part of both triangles. You have to make sure you recognize that, okay? And then I'm going to actually pull this apart. I'm going to pull this apart after I do a few things, okay? They're showing us that side BC is congruent to side DA. So these two sides are congruent. They're also telling us that they're parallel. Well, you have to remember now this. If I have two parallel lines cut by a transversal, then this angle right here will match that angle right there. That is always the case. Anytime two parallel lines are cut by the transversal, but it has to be the line that's cut by the transversal. So there's a couple marks I can mark up here. If you'll take a look at this, this angle right here is not the one I can mark. That is not the one I can mark, okay? So watch what I will mark. I will mark this angle right here because that's the transversal hitting the parallel line. It's always the transversal hitting the parallel line, okay? And so down here on this one, it's the parallel line cut by the transversal. So those are the two angles that would be congruent for this shape. Does that make sense? Okay, I'm going to pause for just a second. Okay, so because I'm able to mark those now watch when I pull apart the triangles and show you what we've got. So I'm going to draw this triangle and I'm going to mark B, C, A, and I'm going to mark here. I'm going to mark my mark there, and then I'm going to put two marks here because that's the side I'm pulling apart. So now watch when I pull apart this one. It's here. I've got A, I've got C, I've got D. I'm going to put the mark here. I'm going to put my angle there that I marked because of the parallel lines cut by the transversal, and I'm going to put two there. That side, AC, is the one I was talking about that is the exact same for both triangles. So when it's pulled apart, it's the exact same still for both. And therefore, we call that reflexive. And because of that now, we have side, angle, side, and we have side, angle, side. So we've proved that it works by side, angle, side. So it's yes, by, side, angle, side, and then obviously the statement is still good. But I wanted to show you that it doesn't matter how you give your first three letters, it only matters how you give your next three letters. So if I say, I'll do this in black, triangle, I'm going to say BCA. that will be congruent to, now watch, and we got to match it up correctly. If I say BCA, so BCA, so watch what I do. I'm looking at B, I'm going to find the letter that matches B. So there's 1 mark to nothing, so go find 1 mark to nothing, 1 mark to nothing, that's D. And then C, you would think C goes with C, it doesn't, so watch. C has 1 mark on it, A has 1 mark on it. And then A on my picture has no mark, but it comes from 2 to nothing. So go find 2 to nothing, and that's C. So it never matters how you give your first 3 letters. It only matters how you give your next 3 letters, okay? All right, we're on to the next step. Okay, in this diagram we have segment QS and segment PR, or RP. They pass through the center of our M circle. What can I conclude about triangle MRS and triangle MPQ? Well, let's take a look at them. A couple things I want to point out about the lines that are cutting through this shape, they're diameters. But what else do we have creating in this shape besides diameters? Well, we have radiuses, and we call them radii plurally. So the moment you have a radii in a circle, all the radii in the circle are congruent. Every single radii in this thing will be congruent. So this one will be congruent with that one, this one will be congruent with that one, and so on, because they're all the same radius. So now what I want to do is point out that we have vertical angles. And so because we have vertical angles, I'm going to show you that. And now triangle MRS, this one, and triangle MPQ, they are going to be exactly congruent because we have side, angle, side, angle, side, and they match up for both. So we'll say triangle MRS is congruent to triangle MPQ by side, angle, side. And it's only because we were able to do that. But you have to understand that those are radii, and every radius in a circle is going to be the exact same. That's why I was able to do the blue markings. And then because we had 2 lines cross each other, that's back to our original statement of vertical angles from this picture, and you're able to come up with the correct terminology that side, angle, side works. So that's why we were able to say that on this picture. All right, so let's bring it down to this one. So I hope you're getting the idea on this lesson that you're going to be looking at 2 different shapes, 2 different triangles, a whole bunch, and you're going to be able to solve different problems or tell whether or not they're congruent on different things. Now, if something's congruent to something else, then you are able to set it equal to that eventually, and go forth on some of those problems like that, okay? Okay, you're going to make a canvas sign to hang in the, on the triangular portion. We're going to make a sign that will go in those triangular portions of the barn shown on the picture. You think you can use 2 identical triangle sheets of canvas. You know that segment RP is perpendicular. That's what that symbol means, the upside down T. Perpendicular, meaning it hits and makes a 90, with segment QS. So here it is right here, RP to QS, and it makes the 90, okay? Well, if that's 90 there, let me just help you. That's 90 on the other side. So we'll do that in green real quick. That's 90 as well, okay? So right now we have a couple angles that are congruent to each other. And then also it says that PQ is congruent to PS. Well, PQ is this one, and that's already marked. So that one's marked already, and this one's marked already, and those are congruent to each other. Well, if that's the case, we know a couple of different things. There's a couple different things you can really tell about this triangle. The moment that happens, that's called a median, because it hit the very center point, cut that in half and made a 90. Well, this triangle itself is isosceles. So we actually could go start marking a whole bunch of things. But the one we're really gonna mark is the piece that goes right down the middle for both triangles. Why? Because it's congruent for both triangles. So I actually can put 2 marks on that one. So I'm going to pull it apart and show you what I think. All right, so we're gonna draw it. We got our 90, we got 1 mark, we got 2 here. We're gonna pull it apart. We got our 90, we got 1 mark, we got 2 marks. Okay, we've got R, R, P, P, S, and S. And I am going to conclude that the 2 triangles are congruent because of side, angle, side, side, angle, side. I'm sorry, that one's not very good. Okay, so we're going to say yes, congruent. By side, angle, side. And we prove that. Okay? Again, we call that reflexive. When you pull it apart, it's the same on both pictures. That's called reflexive. Okay? All right, here's the last one. You're designing a window to show in a photo. You want to make triangle DRA congruent to triangle DRG. You design the window so that segment DA is congruent to segment DG. So DA is congruent to DG. I'm going to mark those already. Okay? Because you said that they are congruent. You made them the same length. Angle ADR, so let's find that. Angle ADR, so that's this one right here, is congruent to angle GDR. GDR, so that's this one up here. Okay? It says you use the side angle side congruent theorem to prove that these are congruent. So that's what's marked already. Now you're going to have to decide something. Well, we want to prove that those triangles, DRE, DRA, so DRA, this triangle right here, is congruent to, and I'll do this one in red. I guess that's not a very good color to use. I'm going to use black. So I want to prove that it's congruent to this black triangle. So the blue one's congruent to the black one, okay? That's what I'm trying to prove. Well, right now we have a side and an angle marked and a side and an angle marked. But when I pull the picture apart, we can easily count straight down, and this side will be the exact same for both triangles. So what can I prove? I'm going to pull it apart and draw it. We have a 90 angle mark there, 2 marks here, 1 here. This is D, R, A. Same picture, D, R, 2 marks, 1 mark, and G. And again, by side, angle, side, side, angle, side. Yes. Congruent. By side, angle, side. And this proved it. Okay? So you're going to use some of those things to help you decide and solve some of the problems that you're going to use. Don't forget that some of the things they're going to give you will be like, they're going to give you numbers. They're going to go say find X or find Y. Just remember, anything that is congruent to something else, you can set equal to it. Remember, angles will get set equal to angles. Sides will get set equal to sides. Okay? And you can either do it by looking at the diagram of the statement, or you can look at it through your markings on the picture. Good luck, and we'll see you next one.